Okay, we're going to be talking about the physics of gravity, and we're uh, involving students who do not yet have a physics background or a lot of math background. So we're going to be doing this in a way that is very accessible to new students to physics. So on the first day, we will talk very little about gravity, really. We're going to talk about basic physics, particularly matters involving conservation laws, conservation of energy, conservation of momentum, and how we can use those to understand physics problems. On the second day, we're going to talk about Galileo. And Galileo was one of the people who first really started to study what gravity does, though very little was known about it at the time. So students now who don't know much about gravity are very much like Galileo. So we're going to review how Galileo had to think about physics in order to understand something very new. That same day we will talk a little bit also about Isaac Newton and how Isaac Newton started to look at the same problems as Galileo did, and that will conclude that day. Now, any student of gravity knows that things, planets, moons, go around other objects, and so we have to talk about rotation. So on the third day, we're going to talk about the physics of rotation, much like we did on the first day for momentum and energy. That will lead us to the idea of orbits, how the moon goes around the Earth. Then on day 4, we're going to take that seriously and study Kepler's laws. Kepler is the person who really put down for the first time the laws that govern the motion of planets in the solar system. And there's a lot that we can do with that. Some of it would be very complicated, and we're not going to do that, but we're going to try to look at orbits of planets, of moons, of satellites in a way that uses Kepler's laws and helps us understand Kepler's laws. Then by the last day, we don't want to leave a week talking about gravity without talking about big gravity, how gravity rules the universe. So we're going to talk about some very big things, from the very origins of the universe in the Big Bang to how the first galaxies formed, how the first stars formed, and how that structures the universe as we see it today. And some of the very exciting things that are happening in science research today using the physics of gravity. Now, all of that is very, very complicated even for me. So we are not going to do complicated physics of gravity today. But there's a lot of interesting things that we can talk about without having to get extremely complicated. So I hope we can end the week with a very interesting, forward-looking view on what gravity is doing in the world today.